Nakikita niyo na ba yung share screen? No. Nakikita niyo na ba?
Opo, sir.
Okay, so our next topic is about binomial distribution. So, ito yung mga type of probability distribution that are being used in research para ma-identify kung ang isang experiment ba or isang theory, isang problem ay feasible. So, binomial distribution, from the word binomial, binomial means two. So, ibig sabihin, ito ay naka-base lang sa two probable events, either success or failure. So parang remember yung previous discussion natin before, the probability of success, probability of failure. It has something to do with this, kung ano yung magiging outcome ng isang problem. So it also follows the binomial probability rules na discuss natin last time. Like, ayun nga, ang probability is ranging from 0 to 1 kasi 0 means probability of failure and 1 is probability of success. So in between 0 to 100%. And then we also have this addition rule, additive rule, the multiplication rule, and then ito yung if A and A prime are two mutually exclusive events that are together, include all possible outcomes, then yung sum nila is equals to 1. The probability of the sum of their probability is equal to 1. The addition rule, the probability of a specified outcome is the sum of the probabilities of the mutually exclusive events making up the outcome. And the probability of an event that is simultaneous to occurrence of two or more independent events. So, discuss ito natin last time. Pag gano'n naman, ang ginagawa is to multiply. Now, let's try this example. So the population of human beings can be classified as having type O blood or not having type O blood. So there's no way that we can get exact information about an entire population since this group is so large. So ginawa is to get a proportion, or sorry, get a sample from that population. So it has been estimated that the proportion of people with type O blood is 0.40 and the rest is from other types. So assume that the estimate is correct. If you observe a single person selected at random, the probability that the person will have type O blood is 0.40 while the rest will have 0.60. So, so yung outcome natin, it's either type O or not. So, ganun pa rin yun. So, we have two outcomes and four possibility for arrangement. And then we have 16 outcomes. So, yun na nga yan. Yung not O, and then kung O, it represents by O. Okay, so a binomial experiment is an experiment in which there are only two possible outcomes. Yun na nga yun. The experiment is repeated n times, that is, there are n trials. So for every experiment, meron siyang n trials na tinatawag. So yung probability of success, the pi is constant from trial to trial. So kung ang probability of success mo is 0.4, every trial, 0.4 ang 0.4 ang kanya probability. The trials are independent and of each other, and we are interested in y with the number of successes with 0, 1, 2, and so on. So, ginagamit natin formula, the symbol ny is read the number of combination of n things taken y at a time. So, we have n of y, ang basa natin dyan, is equals to n. Ano nga yung parang exclamation point? Anong tawag natin dyan?
Factorial.
So, n factorial over y factorial multiply by n minus y factorial. So, yun yung tatandaan natin formula. So, yung n is the number of combination or yung number of trial, and then y is the yung trial mo na gagawin taken at a time. Doon sa kanina example, so meron tayong 4 patients, and then we have 2 outcomes, which is O and not O. So we can denote that as 4 of 2. So the symbol NY can be applied to the blood type example. So the number of 2 different places that 2 can appear in a sequence of 4 symbols that's taken 2 position out of the 4 possible positions. So if first, second, third, fourth at the position, then ito ang natin. So we have B. Ito yung tatandaan nyo kasi we're looking for the binomial distribution table. So we have the B, the number of trial, and then 4 is the number of possible outcome, and then 0.4 is the probability of success. So kung i-compute natin yon 4, 0, ito yung 4 of 0.4, yung probability of success, 1 minus 0.4. This is the probability of failure. Okay, so we have to solve first this one. Ano yung 4 over 0? Ano yung probability of 0? N factorial over n factorial over y. Y factorial, n minus y. Y factorial, n minus y factorial. So, solve na natin siya in case of this one. So, that is 4 factorial. Sorry, wala kasi akong pansulat n. So, 0 factorial 4 minus 0 factorial. So, 4 factorial is 4 times 3 times 2. That is 12 times 2, 24. 0 factorial is 1. 4 minus 0 is 4. 4 factorial is 24. So, that is equal to 1. So, ito yun. So, 0.4 raised to y, that is the number of trial. So, 0.4 is 1. So, ang solve na lang natin is 1 minus 0.4 raised to 4, which is 0.6 raised to 4, equal to 0.1296. Okay, question ba dito? May question kayo? Question? Nakuha niyo ba to, yung process na to? Kuha ba? Itong part na to is the probability of success na part. Ito naman is the probability of failure. So, nakuha ba yun? Kuha ba? Okay, so let's try another example. This one. Yung 1. Dito naman tayo sa 1. So, 1. So, magiging, ang formula na niya is 4 of 1. So, 0.4, probability of success, raised to, this time it is 1. 1 minus 0.4, 4 minus 1. So, 4 of 1 is 4 factorial, 1 factorial, 4 minus 1 factorial. So, that is 4 times 3 times 2 times 1 over 1. 1 factorial is 1. Multiply by 4 minus 1, 3. 3 factorial. So, that is 3 times 2. So, cancel out. Ang sagot is 4.4 raised to 1 and then 0.6 probability of failure 0.6 raised to 3. So, ano sagot dito?
.3456 po.
0.3456. Okay, question. Question ba? Nakukuha niyo na ba? Question? Okay, if wala kayong question, please answer this one using your annotate sa Zoom. Try to answer this 2, 3, 4. So I'll be watching you as you answer and then check natin kung tama. Okay? Ano sagot dito?
May time kasi minsan ang tagal mag-open. Yan. May time. Oo. Kaya ko minsan.
Sir, sa number 2 po, 0.115.
Dito ba yan sa number 2?
0.1152 po. May 2 pa po.
Yung next.
Kami yung mga computer.
Sa 3 po, 0.0512.
0.3.
0 po. 0.0512.
And yung last.
0.0256.
So, violent reactions. Meron ba kayo dyan? So, anong implication nitong ano na to? Itong table na to? It implies that yung mas mataas yung probability na merong isang type O dito sa experiment na to kaysa sa iba. Halimbawa, mas mababa yung percentage, 11.52% lang, na magkakaroon ng dalawang type O. O kaya, 5.12% lang na magkakaroon ng tatlong O. And then, mas malala kung 4. So, 2.56% lang. So, ang pinaka mataas yung probability is yung 1. Okay, question dito. So, it's more of memorization ng formula for you to compute for the binomial distribution. Okay? Okay, now, how do we apply binomial distribution sa hypothesis? So, let's try an example. Because dairy farmer needs more cow than bull, it would be advantageous for them if a method could be found to change the approximately 1-to-1 sex ratio found in nature. So, many biological experiments have been performed in an attempt to alter the ratio kasi mas priority nila ang cow kaysa sa bull. So, either by trying to separate the sperm cells which produce male offspring or by finding some way to inactivate them so that they cannot fertilize an egg cell. So, productive physiologist believes that by treating semen of the bull with a mild acid and using artificial insemination, he can change the sex ratio of the calves. So, he decides to perform an experiment and observe 20 calves that had been produced by this method. He's going to use statistics in order to generalize the result from these 20 calves to an entire population of calves that could be produced by this method. Thus, the statistical procedure begins at this point prior to the actual experiment. So, ito pa rin yung ating mga process. So, state the null, state the alternative, establish the significance level, level of rejection, and the region of rejection. Perform the experiment and observe the outcome and draw the conclusion. So, meron lang konting pagbabago doon sa method na ginawa natin last time. So, instead of yung sa discussion, so we specify yung ating statistical analysis na gagawin. So, establish alpha, the level of rejection, the region of rejection, perform the experiment, and observe the outcome. So, for step 1, state the null hypothesis. So, yung sa experiment na to, so ang kanyang, yung pag-alter ng kanyang baka para maging mas prominent ang babae kaysa sa lalaki. So, yung null hypothesis mo would contrast your ba yun yung ating ginagawa. Ang null hypothesis will contrast your problem. So in case doon sa kanina ay doon sa problem natin, ang null hypothesis mo is that walang changes kasi kinokontra mo nga na mayroong significance na pagbabago yung ratio ng cow sa bull. So kaya kukontrahin mo yon. So you stated that the null hypothesis is equal to 0.5. So meaning, equal ang distribution nila, 0.5 sa cow, 0.5 sa bull. Okay. In other words, the treatment has no effect on the sex ratio. The theoretical probability distribution, if the null hypothesis is true, by, ito na yun, yung ating binomial distribution, y, 20 ang ating sample, yung n natin, n 0.5 is the probability of success. This experiment can be done in such a way that satisfies the 5 conditions of the binomial experiment. So there are 2 possible outcomes, yung babae or lalaking cow. There will be a repeated number of trials of 20 if the null hypothesis is true, 0.5 for each trial. The 20 cows can be selected at random and the semen can be uniform, can be also be selected at random from different pools, ensuring independence from trial to trial. The physiologist is interested in the statistics why, in this experiment, the number of female calves born. So, contradict to the null hypothesis, we state the alternative hypothesis. In this experiment, the alternative hypothesis is yung pi natin is not equal to, not equal to 5. So it is a not equal to 5. Ibig sabihin, either magbabago.
Sir, excuse lang po. Magbubukas lang po ako ng gate, saglit lang po.
Okay.
Sige ba, thank you po.
Okay. So yan. So not equal to 5. So since the physiologist does not know ahead of time what effect of mild acid will have on the sex of newborn cubs, this is a two-sided test or two-tailed test. So kaya ang ginawa is not equal. Kung one-sided kasi yan, ibig sabihin, hindi niya, kasi, bakit ito naging two-tailed test? Unang-una. Kasi hindi mo alam kung ano epekto nung ilalagay mong acid dun sa semen ng baka. Now, hindi mo alam kung magkakaroon siya ng effect in terms of mas tataas pa ang babae na sanggol o yung calf or mas madami yung lalaki na calf yung epekto. Kaya two-tailed test ang ginamit. Pero kung halimbawa na-proven na yung acid na yon na mas tataas ang percentage ng newborn na female kaysa sa male, then magiging one-tailed test na tayo. It's either ang magiging alternative hypothesis na natin is greater than 0.5 kung one-tailed. Pero kung dahil nga ito ay hindi mo pa alam ang effect ng acid na yon, we assume that it is a two-tailed test. So he will reject the null hypothesis. The outcome is an extreme case in either tail of the binomial distribution. Okay, looking at the binomial distribution table, ito yun. Meron ako ibibigay sa inyo ng binomial distribution table, but this is the portion of that distribution table. So either i-submit ko sa ating Google Classroom. So looking at the binomial distribution, yung y20.5, he wants to set a rejection level as close to 0.05. So yung significance level natin dito is 0.05 or 5% as possible because this is a traditional level use. Since this is a two-tailed test, he wants to reject the null hypothesis if he obtains an outcome with a probability of less than 0.025 at the either side of the distribution. Ito yung nangyayari kapag two-tailed test ang ginagamit mo. Kung ang significance level mo is 0.05, so one-tailed test, ito lang ang i-consider mo. But kung two-tailed test yan, kailangan mong i-divide yung 0.05 by 2 to look for the upper and lower limit ng region of rejection. So kaya naging 0.025 at the either side of the distribution. Okay. Okay, looking at the binomial distribution table, this is already computed. Hindi na natin kailangan mag-compute yung n factorial over y factorial times n minus y factorial multiply ng probabilities of success raised to the number of trials multiply by the probability of failure minus the probability of n minus y. So, hindi na tayo titingin sa ngayon. Kailangan na lang natin tumingin sa distribution table. And based on the distribution table, ang titignan na natin ay itong part na to. So, since hanggang 20 tayo, ito yung ating hahanapin na region of rejection. So, sabi niya dito, he wants to reject the null hypothesis if he obtains an outcome with the probability of less than 0.025 at the either side of distribution. So, ano yung mga yon? Sa 0, sa 1, sa 2, sa 3, 4, 5. Ayan, stop na tayo dyan. So, ang ating region of rejection is 0 to 5. Ano naman sa bottom line? Sa 20. So, 0, 0, 0, 0.001, 0.005, and 0.0015, which leads us to 15 to 20. So, ang ating region of rejection is 0, 1, 2, 3, 4, and 5. And 15, 16, 17, 18, 19, and 20. So, if ever na yung experiment niya falls in this region of rejection, then he will say that walang effect yung ating ginawang experiment dun sa semen. Okay, just let me take a look at the okay. So, ayan. So, ito yung ating region of rejection. Now, here. So once na-establish mo na yon, then we perform the experiment. So, yung ginawa natin is a statistical analysis. Now, we perform the experiment. The experiment is now performed and suppose 6 males and 14 females are born. So, ito yung mahalaga sa atin na part, itong 14 females. Kasi ito yung ating binabantayan. If the null hypothesis is true, the expected number of female calves would be, the expected value to so n multiply by the null hypothesis, yung probability natin. That is 20 times 0.5. So, 10 dapat ang maboborn na female calves. However, sa experiment, it resulted to y is equals to 14. So the physiologists cannot be especially encouraged by the deviation of only 4 from the number expected by chance alone. So, ibig sabihin niya, hindi natin siya pwedeng agad-agad na sabihin na may effect kasi 14. So, in deviation ng 4 is not sufficient para masabi mo na nagkaroon ng effect yung acid. However, in the statistical procedure, dun sa ating ginawang statistical procedure, decisions are based on the probability. And the probability of deviation of this magnitude or greater when the treatment is ineffective is needed. So, since yung ating region of rejection is 0 to 5 and 15 to 20, so ano masasabi natin? The A level and the region of rejection merely specify prior to the experiment those outcomes that we considered plausible and those that would be unusual when the null hypothesis is true. In this experiment, outcomes of less than 6 or more than 14 occur only 0.042 of the time the null hypothesis is true. So since yung y natin is 14, wala siya dito sa region of rejection. So therefore, hindi natin pwede i-reject yung null hypothesis. Ano ibig sabihin nun? Ibig sabihin, there is no statistical evidence that may effect yung ginamit na acid sa pagkakaroon ng anak ng mga bata. Hindi nagkaroon ng alteration sa kanilang gender dun sa mga pinanganak na baka. Okay? Question? Question. Medyo mahirap ba or madali yung ating binomial? So ano lang yung tatandaan natin? Kapag tayo ay nag-experiment, state the null, yun yung ating contradict sa ating problem. And then, the null hypothesis, the alternative hypothesis will contradict the null hypothesis. So, follow doon po natin sinasabi. Establish the level of rejection and the region of rejection. And say level of rejection, kung 0.05 yan, that is the usual significance level na ginagamit natin for our rejection level. And then, look at the binomial distribution table. Kung 20 ang n mo at 0.05 ang ating significance level, then we look for the table where the number of n occurs. Then, follows kung saan yung 0.025 kung yan ay two-tailed and 0.05 kung yan ay one-tailed. And then, add the result. Kapag lumampas sa 0.025, do not include it. Like for example, this one, 15, 5, so 20, 0.02, 0.021. Pero nang inad mo na yung 0.037, lampas na siya ng 0.025. So you have to exclude that from the list. And then also here, 0.15, 0.015, 0.005, 0.001, that is 0.021. So hanggang dun lang kasi pag dinagdag mo na itong 0.37, it will not be less than 0.025. So if that's the case, the region of acceptance is this one, this part, 6 to 14, and the region of rejection is from 0 to 5 and 15 to 21. Once you set the region of rejection, then find the result of the experiment. So it turns out that meron siyang 14 females. So look for 14 in your region of rejection. Nasa region of rejection mo siya. Wala. So, hindi mo siya pwedeng i-reject ang iyong null hypothesis. Okay? Question? Question?
Wala na po, sir.
Naintindihan niyo ba? Mahirap talaga tong subject na to. Ako na nagsasabi. Pero, alam yan, madali pa to. Ito yung pinakamadaling probability distribution. Actually, itong binomial. So, kung nahihirapan na kayo from this start, mas mahirap yung mga susunod. Okay? Another example is that the staff of a reading clinic is interested in determining the sex ratio of children who have a certain reading problem. The children reading reverse the letter sequencing word. For example, they read saw for was. So instead of was, yung mababasa nila, they read it as saw. Someone has claimed that more than 70% of the children with this disorder are boys. So the staff decides to look at a random sample of 20 children who have this reading problem. So the null hypothesis is yung pi natin is equals to 0.7 kasi 70% ka daw ng children, and alternative hypothesis is not equal to 0.7 because they are looking for the evidence to substantiate the claim. Assuming the null hypothesis is true, they use the binomial distribution of 20.7 as that theoretical model. The number of boys in the random sample of children with this disorder is represented by Y. Okay. So, meron na tayong null hypothesis, this one, and the alternative hypothesis. So, the level of rejection is, ang gamitin natin is 0.05. So, nagbago lang, kung mapapansin nyo, the problem is similar to the previous problem. It's just that, nagbago lang ang ating probability. Naging 0.7 na yung kanyang factor na mas mataas yung boys over the girls. Okay. Nalaman na natin yung null, nalaman na natin yung alternative hypothesis. Now we look for meron na rin tayong region of rejection. We look for level of rejection. We look for the region of rejection naman. So, balik tayo sa ating binomial distribution table. Hindi na natin kailangan mag-solve. Ano ang mga included sa region of rejection? So, dito tayo titingin, di ba? Sige nga, sabihin nyo kung hanggang saan yung ating region of rejection. Do we include 0?
Opo.
Yes.
Yes. 1?
Opo.
2? Yes.
Opo.
Kaya na natin lahat ng 0. Okay, do we include 7? 7.
Opo, sir.
How about yung 8? 0.04? 0.004?
Opo.
How about 9? 9 to no?
Opo.
Okay. How about yung 0.031? Na 10?
Hindi po.
So, stop na tayo dyan. So, hanggang 9 lang tayo. So, 0.012 plus 0.004, that is 0.016, 0.017. So, 0.017 is less than 0.025. Sa baba, to include 20? Probably yes. How about 19?
Opo, sir.
How about 18?
Hindi na po.
Yan. So, we stop there. So, the region of rejection is from 0 to 9 and 19 to 20. Okay, tanda na yan. 0 to 9, 19 to 20. So, balik tayo doon. 0 to 9 and 19 to 20. Now, if the resultant is 11, ano ang magiging conclusion natin? If dun sa 20 na kinuha niya, ang lumabas na result na lalaki ay merong problema sa reading is 11 ang naging anong ating magiging conclusion? Halimbawa,
Accept the null hypothesis po.
Yes. So we will not reject. Not reject. Null hypothesis. Meaning, there is no significant difference in the result that yung kanyang assumption na 70% of that children, of a group of children has a problem in reading. Okay? So, nakukuha ba yon? Question? 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 Question mo kaya? Before we proceed with another topic,
Sir, pag po, ang lagi lang po bang tinitignan, yung null hypothesis po, yung i-reject or pwede din naman po, kunwari, yung sa, ano po yun, sa alternative hypothesis, pwede din po siyang tignan. Di ba po dun po sa dulo, nakalagay, not reject null hypothesis. Pwede din po bang sa alternative hypothesis din po tumingin? Or
okay.
null,
So,
null lang po talaga?
parang gagawin mo is, parang ang gagawin mo is, parang nagre-reverse ka na, instead of null, ang tingnan mo, alternative. Pwede din naman yon. Kaya lang, pwede din yon actually. Nasa alternative hypothesis ka mag-base. Kaya lang, babalik ka rin mo ang iyong perspective kasi kapag null hypothesis ang tinignan mo, ang tinitingnan mo is region of rejection. So kapag alternative hypothesis naman ang titingnan mo, then you must check the region of acceptance naman. So kapag pumasok siya sa region of acceptance, yung solution mo, like kanina, dun sa 0.07, ang region of acceptance natin is from
10 to 18 po.
10 to 18. So, ayan. 10 to 18. So, kapag ang result mo is pumasok sa 10 to 18, kung ang pagbabasihan mo is alternative hypothesis, then, ang gagawin mo is you reject the alternative hypothesis. I-reject mo na ang null hypothesis kapag pumasok siya sa region of acceptance. So, parang, kung ako, medyo nakakalito sa akin yun kasi dalawa yung iisipin ko. Pero kung yun, pwede din naman yun. Kaya lang, mabalik ka rin mo lang lahat ng process natin kasi sa alternative hypothesis ka naka-base. Okay? So, pumasok siya sa 11, pumasok siya sa 11, i-reject mo ang alternative hypothesis kasi pumasok siya sa region of acceptance. Okay?
Okay po.
Other question? Okay, so pag wala na, then we proceed with another topic. So, ang next topic natin is about Poisson distribution. So, hindi po ito, ang basa dito is Poisson. Ang basa natin dito is Poisson. So, why po Poisson? Kasi ito ay introduced by a French statistician. So, yung apelido niya is Poisson. So, kaya naging Poisson distribution. So, yung Poisson is a process consist of discrete events that occur per unit. So, kung yung binomial distribution, ang kanyang outcomes is dalawa lang, ito naman, ang kanyang resultant must be in a discrete event. Ibig sabihin, we're not looking at a number that has a decimal places, like yung mga temperature, ganon, iba sa level of measurement natin. But rather, a discrete events, like yung how many times na nagkaroon ng earthquake. So, counting lang naman yun, walang half doon. So, 1, 2, 3, diba, mga 8 times na nagkaroon ng earthquake, or how many times na nagkaroon ng bagyo. Yun. So, discrete events. So, it's more of a counting numbers. So, the probability of a single occurrence of the event is directly proportional to the size of the interval or sampling unit. So, if the sampling unit is sufficiently small, the probability of 2 or more occurrences of the event is negligible. So, halos maliit na lang siya. So, wag mo na siyang i-gawin. The occurrences of the event is non-overlapping intervals or units are independent. That what happens in one sampling unit has no effect on what happens in the other non-overlapping unit. So that would be the condition of the Poisson distribution. Now, if an experiment generates a Poisson process and the units are randomly and independently obtained, then the appropriate probability model for the number of occurrences of the event in the specified sampling unit is a Poisson distribution. So, pasok daw siya sa Poisson distribution. So, the Poisson distribution is a discrete probability distribution with a probability function. So, ito naman, kung kanina we're looking at the y, the number of trials, ito naman, meron tayong introduce na lambda. So, lambda is, may explain natin, that is the expected number of occurrences. So, equal to E, yung E natin sa calcu, which is the natural logarithm equal to 2.7183. Raised to negative ng lambda, the expected output, or expected number of occurrences, multiplied by the lambda raised to y over y factorial. So for y is equals to 0, 1, and so on, in this probability function, y is the value of the random variable. Y factorial has the usual meaning of y factorial. E is the natural logarithm. The base of the natural logarithm equal to 2.7183. And lambda is the Greek letter lambda is the number of expected of occurrences in a specified interval. Now that this probability distribution is completely determined by the parameter lambda, if we know the lambda, we can compute the distribution as in the following example. So to suppose the city has a variable number of suicides per month, but the mean is 3 suicides. But the mean is 3 suicides per month. A mental health scientist wants to study this phenomenon and decide to use Poisson distribution to model the distribution of the suicide data. The sampling unit is 1 month. Y is the number of suicide in that month. And the expected Y or the lambda is 3. So per month kasi merong 3 daw na assumption na nag-suicide. Then compute the probabilities of different numbers of suicide in any specific month. The mental health scientist will use the formula. Okay, so since discrete nga ang ating condition sa Poisson distribution, we're looking for the probability for every month kung ilan yung magiging suicide given a number of average. So using the formula, ito, EY lambda y, y factorial. So we use that e raised to y lambda. Ito ba yung lambda? Lambda. Ito ay lambda raised to lambda raised to y over y factorial. Now, if 1 month, in 1 month, ang ating e is e raised to negative 3. Yung lambda kasi natin is 3 multiplied by 3 raised to 1 over 1 factorial. Ano ang ating sagot? Ano ang sagot dito?
0.15 po.
0.
15 po. 1.5.
Okay, wait. 0.50. Okay. How about kung in 2 months? Ilan kaya ang suicide? Suicide natin doon. So that is e raised to negative 3 multiplied by 3 raised to 2 over 2. Sorry.
$0.22 po, sir.
0.22. So 3 raised to 3. Ito naman ay 3 factorial.
$0.45 po.
So 0.45. So you see, habang tumataas yung accumulative months, tumataas yung chances na magkaroon ng suicidal in a month. So, syempre, ano na yan, yung probability niya habang tumatagal, tumataas siya. So, looking at the table, yeah, so, ito is parang you find ano yung magiging probability in every month. If in 0 month, ano yung probability? Dito sa 1, na-compute na natin, that is 0.15. For 2 is 0.22. For 3 is something. Tingnan mo, titingnan nyo kung ano yung pattern ng probability distribution. If nagkakaroon ba ng increment every dagdag ng buwan, or at a certain month, na-pick niya yung kanyang probability, then after nun, nag-i-slow na yung increment. So, i-check niyo. But it's for you to try this example. Okay, for testing an hypothesis, so syempre, if you want to apply, kung na-apply natin kanina pala, yung sa binomial distribution for conducting a statistical analysis, then we can also use that for Poisson distribution. For example, this one, a biologist studying yeast believes that after certain treatment of cells will be present at a rate of 0.55 per square of hemacytometer. A microscopic plate usually used to count blood cells. He finds 13 yeast in 20 squares and wonder if 13 over 20.65 indicates that the rate of 0.55 is correct. To determine 13 cells in the 20 squares are likely to occur if his conjectured rate is correct, he used the Poisson distribution. Ano yung ating dito? Null and alternative hypothesis. So base sa result, ang kanyang rate is 0.65 kasi 13 yung kanyang nababas. Pero ang pinoprove niya is that is only at the rate of 0.55 yung growth ng yeast cells. Okay. So here we are going to find kung tama yung kanyang assumption na 0.55 lang, not 0.65. So the null hypothesis, ano ang ating null hypothesis dito? Ano ang kanyang ipinoprove? Ano ang ating null hypothesis? 0.65 or 0.55?
Ay, 65 po.
0.65, ito yung kanyang resultant. Kasi nung nag-experiment na siya, lumabas is 13 over 20. But ang pinoprove niya is 0.55.
0.55.
Yan ang ating null hypothesis. Now, the alternative hypothesis is contradicting to the null hypothesis, not equal to 0.55. Or, we can say that kung talagang na-prove niya na talagang mas mataas dapat sa 0.55, we can say that it is greater than. But wala pa naman siyang ganung assumption, so we say that it is a two-tailed test. Okay. Next is, once we establish the null hypothesis, then ang sunod, we find meron din tayo ang tinatawag na Poisson distribution table. So, teka lang. Let me send it to everybody para makita nyo yung ating, although post ko dito, but send natin siya in advance. Yan, nasa chat box. So, try to look for or try to browse yung ating Poisson distribution table. Okay, so paano natin maiintindihan? So ito yung null hypothesis natin. Ito yung alternative. So phi is equals to 0.55. Ito ay not equal to 0.55. 5. Now, ano muna ang ating magiging expected value or yung lambda natin? Lambda is equals to n 5. So, since 20 ang ating sample, multiply by the 5.55. Ano ang ating magiging lambda? Ano ang ating lambda?
11 po.
11. Okay. So, same with, nabuksan nyo naman, na-browse nyo na yung ating, stop share ko lang. We look for ating distribution table. Now, the percent distribution table is something like this. So, we look for the lambda and the y, and then, titignan natin kung saan yung region of projection. So, ang level of projection natin is same what we use in binomial distribution. We use the default mode, the 0.05. So, ang ating total test to, that is 0.025. Same lang na rule na gagamitin natin sa percent distribution if the sum of the trials is equal to or greater than 0.25, then we reject it, or we will not consider it in the region of projection. Since the expected value is 11, yun, then ang ating sample is ilan? Since ang ating lambda, or yung expected value natin is equal to 11 and up to 20 samples. Now, dito tayo titingin ngayon sa table na ito. So, ano ang ating mga i-consider? Zero, 0.02, 0.01, 0.37, kasama pa ba to?
Hindi na. Ay,
Kasama pa ba o hindi na?
hindi na po, sir.
2 plus 10 is 0.12, 0.01, 0.012 plus 0.037. Equal na ba to sa 0. Or mas mataas na ba sa 0.025?
Mas ay, pag sinama po yung 0.37 po, mas mataas na po.
0.4.
Ay, wait lang, sir, hindi pala.
Sasama pa natin.
Apo,
Included pa
sasama
rin.
pa po.
How about yung 1.02?
Hindi na po. Ay, kasama pa po.
Kasama pa. How about ito? Ito, obvious na, hindi nakasama. So, ang ating region of rejection sa lower level is 0 to 4. How about sa upper level? Kasama pa ba yung 20?
Opo.
Yung 0.084.
Opo.
0.145.
Opo.
Kasama pa. So, ito hindi na. So, that is, sa upper level, ang region of rejection natin is 18 to 20. So, 0 to 4, 18 to 20. So, balik tayo doon sa ating problem. Okay, so ang ating region of rejection is 0 to 4, 18 to 20. So, ang lumabas sa kanya is 13. 13 cells in 20 squares are likely to occur of his injection. Conjecture is correct. So, he uses the Poisson distribution. So, pasok siya sa region of acceptance. Ano ngayon na magiging conclusion natin? Anong conclusion natin doon?
Not reject din po.
Not reject the null hypothesis kasi pasok na pasok siya doon sa ating region of
Acceptance.
rejection. So, siya kasama plus doon sa region of rejection. So, tama yung assumption na baka 0.55 ang kanyang growth ng kanyang yeast. Okay? Next. So, Poisson distribution and binomial distribution. Ano yung interaction? O pwede bang pumasok si Poisson distribution sa binomial distribution? So, Poisson distribution is often used as an approximation of the binomial distribution if the number of trials n is large and the probability of success on a single trial phi is small. The approximation is possible because it can be shown mathematically that if phi becomes very small while n becomes very large and the product n pi remains constant, then the binomial distribution will be approximately a Poisson distribution. So, kung daw, ito yung kanyang assumption. Kapag daw yung pi natin becomes very, very small, so halimbawa 0.00 something, and then yung n natin is naman is malaki or very large number, so yung n pi natin magiging constant lang yung value nun. Then, yon ay hindi napapasok sa binomial distribution. It would be computed in the Poisson distribution rather with lambda is equals to n pi. And the Poisson sampling units, the set of n trials. So, for example, paano natin ito i-apply sa ating problem? So, a geneticist believes that in a certain experiment, the mutation rate is 4 in 1,000. She would like to find the probability that in a random sample of 25,000, she will observe no more than one mutation. So this experiment situation is approximately modeled by the binomial distribution, wherein y 25,000 and 0.004 kasi 4 in 1 million. So, ano yan? Yung 4, iuusod mo pa siya number of places ng 6. And she wants to compute, she wants to compute na yan. She wants to compute yung magiging result daw ng probability distribution first in the binomial distribution. So, paano natin siya i-compute?
Yung hypothesis po.
Ano muna natin siya? I-compute lang natin siya using binomial distribution. So, yung P is more than one no more than one mutation. So, ibig sabihin, less than equal to 1. So, yung probability distribution that P y is less than or equal to 1. So, ang probability niyan would come from the probability of 1, rather 0, plus the probability if y is 1. So, ano yun? So, i-compute natin yan sa binomial distribution. That is, ano to? That would be for 25,000 0 multiply by 0.00005 4 raised to 0 multiply by 1 minus 0.0000005 4 raised to 1 minus probability of success 25,000. So imagine nyo, ganyan katataas yung value na i-compute natin. Plus 25,000 of 1 multiplied by 0.00004 raised to the number of success 1 minus 0.00004 25,000 minus 1. Okay, solve na yan.
Sir, undefined po yung una.
Undefined yung pangalawa. Pero pwede yata ito. 25,000 factorial. Kasi masyado na mataas. Kung ipapactorial mo nga yan. Baka yung pangalawa ganun din. No? Tama ba?
Hindi, sir, kasi may mga zero po kasi dun sa...
Okay. Sige. Ang sagot sa pangalawa.
$0.91 po, sir.
0.91.
91 po.
Pero hindi natin ma-add kasi hindi natin alam yung value ng isa. Now, let's try the approach of Poisson distribution this time. So, ang gagawin natin first is to compute for the lambda. Ang lambda natin is n multiplied by 5. Which is, ano magiging sagot? 25,000 multiply by 0.00004. Anong sagot dyan?
Zero point one po.
0.0.1.
1.
Okay. Now next is ganun ulit. We find for the probability E if Y is less than or equal to 1. So that is the probability of 0 sa Poisson distribution if lambda is 0.1. Lambda is 0.1 and then plus the probability that 1 for lambda 0.1. Okay. Now, ito muna tayo sa una. Equal to E raised to lambda 0.1 negative multiply by lambda 0.1 raised to 0 over y factorial or 0 factorial plus E raised to negative 0.1 the lambda multiply by 0.1 raised to 1 over 1 factorial. Sagot.
Sir, yung sa E po ba, negative 0.1 or 0.1 po lang po?
Negative. E raised to negative lambda yan.
Sir, di po siya makapag-plus kasi parang nag-error po siya. Tapos yung una naman pong nag-undefined po siya. Kaya, ang ginawa ko po, pinaghiwalay ko na lang po siya muna. So, 0.99 po yung sa may pangalawa, yung sa may 1 na po.
Okay, sige. Na kasi ako hindi ko talang calculate sa office. Wait lang. Natin So, yung una muna is E raised to 0.1 negative. That is 0.09 multiplied by 0.1 raised to 0 divided by 0.1. So 1. 0.948. 0.048 plus e raised to 0.1 negative multiply by 0.1 raised to 1 divided by 1. 1 factorial is 1. Ang sagot is 0.9959953. Paras ba tayo?
Hindi po,
0.995.
sir. Pero, magkalapit po. Kasi hindi ko po sinama yung sa may 0 po kasi nag-undefined po siya.
0 factorial is 1. Baka doon siya nag-error.
Nakalagay po kasi, too many variable daw po.
Anyway, sa libro, ganun din yung sagot. 0.9953. So, ang implication lang nun, kanyang itong ano na to is if hindi siya kayang isolve ng binomial distribution dahil nga too many values, there's a large value of n and yung namang probability mo is too small, then you can use a Poisson distribution to compute for the probability. And from that probability, kung naman natin sa problem, we can conclude that talagang kung pagbabase ako naman tong problem na to, yung kanyang conclusion nung nag-experiment, yung geneticist, she can conclude that there is no more than one mutation kasi 99.53% ang kanyang resultant, ang probability niya na walang magkakaroon ng mutation ng more than one. So yun na yung parang pero sa practicality, when it comes to Poisson distribution, it can be used as a substitute for binomial distribution with the condition that yung n mo is sobrang taas and then yung kanyang probability naman of success is sobrang. Okay, question? May question ba? Okay. Wala na ba? May question ba kayo? Naintindihan nyo ba? Question?
Sir, meron pa po bang isang example sa Poisson distribution?
Sa Poisson distribution. Anong example? Hypothesis?
Yung katulad po nung last po.
Ay, itong Poisson distribution and binomial. Ito ba o isa hypothesis?
Opo. Ayan po.
Alin ba?
Ayan pong and binomial distribution po.
Okay, sige. Wait lang. Tumatawag lang. Hello? Oo. Yes. Wala po. Ano pa lang ko postpaid? Oo. Okay, hello. Sorry, may tumawag. Ano, yung sample. Sorry. Nagkahanap tayo, Ayan. Yeah. Another example is we have if the rate of accidental drownings per year is 0.003, 3 per 1 million population, what is the probability that there will be more than 2 drownings in a city with a population of 400,000? So let's try first to solve this by binomial distribution, which obviously is hindi na tayo papasok dyan kasi we satisfy na the condition that meron tayong 400,000 which is a very large sample, and ang ating ang ating probability of success is too small naman. That is 0.003. So, do we need to solve for binomial distribution na pa dito? Sige, kung gusto nyo, solve natin siya. So, P that the Y is less than or equal to 2. So, 2 kasi ang ating. So, that is the sum of the probability of y is 1, plus the probability that y is 2, and the probability, nalimutan ko is 0. The probability that there will be no drownings. So, going back, so for P1, that is 400,000 rather, of 0 multiplied by 0.00003 raised to 0 multiplied by 0.00003 raised to 400,000. Plus, yun, kung 1 plus 2. Hirap isulat eh. Panulat. Sige nga, try nyo nga munang isolve to kung ito ay 400,000. Yung 400,000 of 0, that is 400,000 factorial over 0 factorial minus 400,000 minus 0 factorial. So that is 1. Ito is 1 na to. So ito ay 1. Ito ay 1. Ito na lang problema. What is this? 0.003. Tama, 5 zeros. Raised to 400,000. Ano sagot yan? Sagot. Ay, sorry. Hindi pala 2.003. Ito ay 1 minus probability of failure. 0.003. Anong sagot ko? May kausap pa ba ako? O nag-leave na kayo?
Meron pa po, sir. Kaso undefined pa rin po. Tinitignan ko pa po kung paano yung i-compute ng mas maayos.
Wala na akong kausap eh. Ito ay 1. Ito ay 24,009. Kung na mag-solve din ako. Okay, tapos yung isa is multiply by okay, so parang ito na yung kanyang buong probability distribution computation. So 400 of 1 multiplied by 0.0003 raised to 1 multiplied by 1 minus 0.0003 raised to 399,999. Kasi 400,000 minus 1. Sa pangalawa, 400,000 of 2 multiplied by 0.00003 raised to 2 multiplied by 1 minus 0.00003 raised to 399,998. Kung yan ay binomial distribution ng computation. Kung punta naman tayo sa Quotient, that is y is less than or equal to 2. Ganun pa rin, the sum of each 1 plus 2 plus P3. So kung P1, that is E raised to, teka, ano mo ng lambda? Lambda is 400,000 multiplied by pi, which is 0.0000. Okay. Sagot dito sa lambda.
$1.2 po, sir.
1.2. So ito ay e raised to negative 1.2 multiply by lambda 1.2 raised to y. Y0. Wala 0, 1, and over 0 factorial plus e raised to negative 1.2 multiply by 1.2 raised to 1 over 1 factorial plus e raised to negative 1.2 multiply by 1.2 raised to 2 over 2 factorial. So, ano sagot dito? Mas madali yung approach niya kaysa dito sa taas na sobrang dami na. Yan. Ano sagot dito sa pangalawa? So, ganyan lang naman kung paano siya isa-solve. Sige, tayo ko yung sagot. Anyone? May sagot na ba kayo?
Zero 0.8795 po.
0. Total na to?
Opo.
Okay. 0.8795. Yan?
Opo, sir.
Okay. So, yun daw yung sagot. Okay. So, if ever na meron kayo if you want to find yung sagot sa probability distribution sa binomial, then i-practice nyo na lang sa bahay. But kasi ito yung mas simpler yung approach, mas maikli yung solution, hindi tayo nagkakaroon ng conflict sa decimal places kasi limited yung kanyang decimal places kumpara dun sa binomial distribution. Okay, question. Pa.
Wala na po, sir.
Okay. So, announcement lang. So, ang ating midterm, isasabay tayo sa midterm ng university calendar. So, ang midterm week is third week ng May, which is 17 to 21. So, ang ating midterm is on the May 21. So, via ganun din, Google Classroom, Google Form ang ating exam. Yun. So, yun lang ang ating. Ang coverage is, syempre, from the start up to Pasan distribution. Then, wala tayong meeting sa stats next week. Kasi nga, na yun, break muna tayo. But I will give some quizzes regarding binomial and distribution next week. So, bibigay ko na lang sa president nyo. Or i-propose ko na lang sa Google Class. Any more question? So, ulitin ko, wala tayong klase next week sa stats lang. Pero, meron akong ibibigay sa inyo na mga quizzes for you to answer prior to your midterm. Para, mag-practice nyo pa yung knowledge nyo sa binomial and quotient. Question? Question? Before we end our class, kung wala nang tanong, I request everyone to please open their camera for our photo op. Okay, bukas po ng mga com. Okay. 1, 2. Great, thank you everyone. And see you sa 21 para sa stats. Kikita pala tayo next week sa automatic. Okay? Bye-bye.
Thank you po, sir.
Thank you po,
Thank
sir.
you. Thank you.
Thank you
Bye-bye.
po, sir.
Ingat.